Yeah. Hello, students. Last session we have done with the introduction of the soft computing. What is meant by soft computing? What are the properties and where we are going to use them? Like that we have seen. Okay. Now, coming to the next topic of our session is what is neurocomputing? Okay. So what is meant by neurocomputing? By the name itself, neuro. Neuro implies neurons. Neurons implies brain, human brain. So the neurocomputing, by the name itself, we can understand that it is a combination of computing technique related to your human brain. So how we are designing artificial neuron with the resemblance of the human brain, because human brain is highly competitive model. Okay, so it will have the complete from day one when you born till when you live, like when we before when we die. So everything it will remember. So everything it will analyze what we have to do if you have any problem, or what we have to do if you feel hungry, how it is going to structure this. So this is the basic beauty of the human brain. So I don't want to tell more about the biological neural networks. So that is not related for us. Just I'm telling how your brain works, you know very well, right? So like that, the complete human brain can be converted into an artificial neural network, artificial competitive model called ANN. So this computing is called as a neurocomputing. Okay, I hope it is clear for you. So what is meant by neurocomputing? So neural computing or neural computation, which is an intersection of neuroscience and computer science. So what is the basic aim of this? In order to generate the or model the artificial neural networks. Okay, so these networks are interconnected nodes. So if you talk about the neural networks, our brain is like connected with all the neurons. So one processing unit is called as a neuron, and each and every neuron will be connected to all the neurons in order to form a network which will give the result. So like that, our artificial neural network will be connected with the neurons. Which neurons? Artificial neurons. So these are also called as nodes. Now, what is the basic thing what we are going to do with the neurocomputing? So, the agenda of the neurocomputing is to go for the parallel processing, learning, adaptation. So, what is meant by learning and adaptation? Okay, so when you are a child, we learn everything. After you're growing up, okay, what you'll do? You adapt all those things. Means you'll implement what you have learned. Okay, so this is called as learning and adaptations. So how the new human brain will do the learning and adaptation, neural computing will also do. So I think you have done so many algorithms in machine learning or artificial intelligence or deep learning. So what you are doing first, you will first train the data, then you will test the data. So training is the learning, testing is the adaptation. So I think it is clear. Now, what we are doing for the next part will draw the complete structure and functionality of the human brain and convert into the artificial neuron. So all these things in depth we'll discuss in the further sessions. Only just you understand that what is meant by neural computing. The basic aim of the artificial neural network is to create an artificial neuron which will take some input as a signal and process it and produce an output signal which will be based on some activation function. So I'll just brief it. You'll have one neuron. Okay, that neuron will take some input, it will process, and it will give the output. So how it is taking the input in the form of the signal, and how it is going to give the output in the form of some signal. So how it is identifying whether the signal is correct or not, it will be depends on the threshold or activation function. Okay, so this is a basic brief introduction of the neural computing. Now, what are the different characteristics of neurocomputing? First one is parallel processing. As the name itself, it will do the task parallelly. Suppose you got a complex problem. So what we will do, we'll divide the complete complex problem into small pieces and we'll distribute among the team and who will work parallelly. So one, that particular module or one task is not depending on other tasks. Though it is depending, what we will do, we'll divide the task in such a way that all the tasks will be parallelly processed. Okay, so this parallelism will help for the distributed processing. Like, for example, you're talking about the human brain. So this will control all the organs of the body parallelly. It will only say that first I'll only control the heart, then I'll go to liver, or then I'll control my like legs like that. So parallel processing is most important characteristics of the neuro computing, where it will parallelly handle all the tasks. Next, as we discussed, what is the next characteristics? Learning and adaptation. So what you are going to do in the learning? First, we will complete the learning phase, then we'll go for the adaptation. So same, as I said, first we'll take the data, we'll train the data, then we'll go for the testing strategy. So what we will do in the training phase, we will create all the internal parameters, or what is the value of the weight, and how many neurons are required, and what are the errors between the predicted and actual outputs. So this particular ability to learn will help in the adapting the neural networks in order to increase the performance over the time. So what we will do, first we will learn the complete data set, we'll train the model, then we'll go for the testing purpose. So while training itself, you will check whether it is giving the accurate result or not. If it is not giving accurate result, what we have to do? We have to change the weight value. So this is an example in the neural network. Suppose if you are going for any other algorithm, the strategy may be different, but learning will be same. And after learning only, we have to go for the adaptation part. Next characteristic was interesting, like fault tolerance. So what is meant by fault tolerance? Okay, so fault, suppose any fault occurs or any problem occurs or any failure happens. So we should not stop there. We should tolerate all those faults. So this characteristic is basically built in the human brain. So that we are adapting in our neural networks with the help of the connection, like if there is any connection failures or any function is not properly working or it is reducing the performance. So we have to overcome all these problems. So this is called as a fault tolerance. Next one is non-linearity. What is meant by non-linearity? So we know that linear means all will work in the same phase. Okay, suppose you have linear problems and non-linear problems. So in the linear problems, the input will be same for every task, but output also may be same. But coming to the non-linear, it will take different patterns of the data or it will produce different types of output. So we cannot predict what type of data it is going to take or what kind of what kind of output it is going to generate. So this is non-linearity. So this non-linearity will enable the neural network to be more accurate, and it will work on more complex relationships and more patterns of the data. For example, so all the time we will not use the same input for our human brain. Your input may be some signal, or you will view something, or you will hear something, or you will talk something, or you will get input from some other resources. So how it is processing? It is processing on the same way and it is providing the result. The result may be different. Sometimes we'll show our action, reaction. Sometimes we will talk, or sometimes we'll shout, sometimes we will laugh. So whatever the input pattern you are taking, the output pattern may also differ. But we can't say that all the input and output patterns are same. So this is a basic example for the non-linear linearity, which can be worked only with the neurocomputing. Next one is generalization. So what is meant by generalization here is will create all the neural networks which are well trained. Okay. And it can also predict the outputs of the data which it has not done previous. Suppose you have one problem. You are doing the weather prediction. Okay, you have trained only up to some certain data. Like you took only some the prediction only for some area wise, some specific area. Again, you are going to test with some other area which you have not trained before. So this can be done with the neurocomputing. So there is no rule that whatever the data which is trained will only be tested. So you can do any kind of data which is not used previously or unseen data. So this is called as generalize. So this generalization can be mainly used in the pattern recognition, classification, regression. So these are all the tasks which can be performed using the neural networks. Next one is scalability. Scalability, as we know, we can work with the high dimensional, huge amount of data. So I cannot say that I'll only work with 1,000 uh, uh, pictures, or I cannot work with only 100 pictures. We're identifying the type of image. So this scalability will be based on your number of internal layers you are having and how you are going to work with that. So this adjusting of the network architecture will improve the scalability. Next one is adaptability to various domains. So we can work in multiple domains. We can go for, as I said, the input pattern may not be same because it is non-linear, right? So what we can do, the input may be image, it may be a speech, or it may be natural language, or it may be forecasting, or it may be healthcare, whatever it may be. The neural network will not say that I'll only work with the healthcare, or I'll only work with the robotics, or I'll only work with the education data sets. So it have to work on various domains. Now, next one is the black box nature. What is meant by black box? Like what exactly happening inside, we don't know. Like we'll give some input, it will be processed, you will get the output. So interpreting the process, how the neural network will work is not so easy, and we cannot understand that. So only the thing is there is no transparency how the neural network will work, okay, in the challenging domains. So this is called as the black box nature. Hybridization. So generally, what is meant by hybridization? Like we can combine different types of techniques with another techniques. For example, I'll take the all the fuzzy logic. I'll implement on the algorithms of genetics, or I'll go with the conventional algorithms, or I'll implement with evolutionary algorithms. So I'll create a combination of all the techniques which are related to the soft computing, and I'll create one good, beautiful hybrid system. So this hybrid system will work for the traditional one, fuzzy logic or evolution or genetic algorithm. So this is called as hybridization. Next one, finally, we can conclude that the neurocomputing is growing in a rapid phase where we are creating innovative neural network architecture. We are going for the different types of learning algorithms, and you'll have the computational hardware, and that can also be used efficiently with the help of this neurocomputing. So if you're going for as a researcher, suppose if you want to explore so many artificial intelligence and machine learning algorithms, so you can work on that and you can increase the computational task and solving the complex problem very easy. So this is our end of the slide. So I hope you are clear about what is meant by neurocomputing and what are the characteristics and where we are going to execute or implement these neurocomputing techniques. Thank you.